Okay, to answer this question, I made this little table here. So when you're comparing these things, these are all one-dimensional things: length, width, height, diagonals of a base, radius, diameter, apothegm, perimeter. These are all 1D measurements. So you would use the 1D ratio to compare them. Area, lateral area, total area, those are all 2D measurements. Centimeters squared, meters squared. Here you would have meters or centimeters or millimeters. Here would be millimeters squared or centimeters squared. Here, volume, I would use the 3D ratio. This is millimeters cubed, centimeters cubed, meters cubed. So I would use a 3D ratio to compare them. Now this question says here, on the right, the two cones are similar. The ratio of height. So 1 over 2 is 2 to 3. Now 1 is smaller than 2. 1 is smaller, so 2 over 3, the fraction is less than 1. So this is a 1D ratio because I'm comparing heights. Height is over here. Height is a 1D measurement. You measure the height using centimeters or meters or millimeters, etc. So I would have to use the 1D ratio, or this is the 1D ratio. So in question A, if this is the 1D ratio, then what is the ratio of the radii? Radii, or radius, is right here. It's a one-dimensional measurement. It's a distance, it's a length. It's measured in millimeters. So I would use the one-dimensional ratio for that. So letter A, it would be a 1D ratio, and the ratio would just be 2/3 to the power of 1. I don't have to do that at all. I can just leave it as just 2/3. Now what's B? B says the ratio of slant heights. Slant heights. So slant height is a height. That's also 1D. That's also 1D. So I could just leave it like this. So the ratio would be the same as the ratio of their heights. So I can just leave it like that, or I can put in brackets and say over 1 if I want to. It doesn't make a difference. Part C, what is the ratio of their lateral areas? Now area, that's a 2-dimensional measurement, centimeters squared, meters squared. So that's a 2D ratio. This is a 2D ratio. So all I have to do is take the 1D ratio and I raise it to the power of 2. So this would be, the 2D ratio would be 4 over 9. 4 over 9. And then the third one is volume. Well, volume is a 3-dimensional measurement. So I would use the 3D ratio. So I would put a 3 here, the power of 3. So this would be 2 to the power 3 over 3 to the power 3 would be 8. This would be equal to 8 over 27. So letter D would be a 3D ratio. So I take the 1D ratio and I cube it. So it's 8 over 27. And letter C would be the 2D ratio. So the ratio would be 4 over 9. So 4 over 9. And A and B are just 2/3 because they're one-dimensional. Now I have two similar cylinders and I have to find the volume of the small one. The volume of the small one. But I don't know the height. But I do know the big diameter and the little diameter. So diameter and diameter, that's one-dimensional. So I can find the 1D ratio. So the 1D ratio would be 1.5 over 1. Or I could also say 1 over 1.5. But let's do it big divided by small. So I'll say the 1D ratio is 1.5 over 1. Diameter divided by diameter. So there we have the 1D ratio. Now if I want to go from here to there in one dimension, all I have to do is multiply by 1.5. So 1 times 1.5 will give me the big diameter. Now if I want to go backwards, I'll have to divide by 1.5. So if I have 9, and I want to go back to the small one, I should divide by 1.5. So now I can find the height of the small one by just saying the height. So the height, how do you spell height? Height of the small one is going to be 9 divided by 1.5. 9 divided by 1.5. 9 divided by 1.5, which will be 6, equals 6 centimeters. So now we know the height of the small, cylinder. So now that's all the information we need. That's all the information we need to find the volume. So the volume of a cylinder is, so the volume of the small cylinder is area of the base times the height. So now we know the area, we can find the area, and we found the height is 6. So the formula for the volume is pi r squared times the height, right? Pi r squared is the area of a circle times the height. That will give us the volume. So pi r squared, and r here, this is diameter is 1 centimeter. So r is going to be half of that, 0.5 centimeters, and the height is 6, we found over here. So we'll put all those numbers in there. So centimeters squared times centimeters will give us centimeters cubed. When we multiply this out, we get 4.71 centimeters cubed for the volume of the small. But there's another way. We could have used the 2D ratio. How would we do that? So the 2D ratio would be the 1D ratio squared, which is 2.25. So I just square the 1D ratio, which was 1.5 over 1, square it, 2.25. So if I look at the big one, I have the diameter, I have the height, I can find the volume. So volume of the big one, so let's find the volume of the big one. It's going to be area of the base times the height, pi r squared, area of the base, times the height. This time the radius is 0.75. So 1.5 divided by 2 is 0.75. That's the radius. So 0.75 squared times the height is 9, and I get, so the volume of the big cylinder is 15.9 centimeters cubed. Now how do I go from the big volume to the small volume? And all you have to do is divide. How do I go from the big volume to the small volume? You just have to divide by the which ratio? Well, if it's the volume I'm comparing, well, okay, it's not the 2D ratio, it's the 3D ratio. I have to find the 3D ratio. So what is the 3D ratio? Well, it's going to be the 1D ratio cubed. Let's find that. So since I'm comparing volumes, I have to divide by the 3D ratio, which is 1.5 over 1 cubed, which is 3.375. So my volume of the small one is, another way of doing it is take the big volume divided by the 3D ratio and get the small volume. Let's see if that works. So when we divide the big volume by the 3D ratio, we should get the small volume. And when we do it, we do get the small volume. It's 4.71. There's two different ways of doing this. Okay, so let's go back up here, 1 centimeters cubed. So let's go back up here and look at this right here. So if I have the volume and I have the big volume and I want to go to the smaller volume, I'll divide by 3.375. That's the 3D ratio. If I want to go from the big height to the small height, I have to divide by 1.5. That's the 1D ratio. And the other way around, if I'm going from the small height to the big height, multiply by 1.5. If I'm going from the small volume to the big volume, multiply by the 3D ratio.